And hello to all my young friends who are studying in intermediate and they are watching this video. My name is Salman. Very recently, I have started my online educational platform. Today, we are going to discuss a topic from mathematics. And the name of the topic is transformation of axes. In fact, this is a topic from coordinate geometry. So let's start transformation of axes. Transformation of axes is probably the second chapter which is taught in coordinate geometry after locus. But at times the student find it a bit complex, so they skip this, probably thinking that it is not that important. But I'll tell you it's very important, and the reason I'll be discussing very shortly. So we'll start with transformation of axes. Now, what does transformation mean? The word transformation means to change. At times, you say that the naughty kid who was playing around, now has transformed into a handsome young man. That means he has changed. The same thing applies here also. Here also, the transformation means change. And here we are telling about transformation of axes. What is axis? You have x-axis and you have y-axis. So put together, they are called axes. Axis is plural of axis. Anyway, so we'll discuss how the transformation happens or how it can be done, and what happens when the axes are transformed, and also we'll discuss what are the advantages of this. So axes can be transformed in following ways. There are three ways in which axes can be transformed. Translation, which we'll discuss shortly. Actually, it means that you take the axes parallel to themselves anywhere. Rotation, you rotate the axes. Then translation and rotation, where you do both the operation, translation as well as rotation. Now, when the position of axes is changed, that means when transformation happens, what happens after that? Logically, coordinates of the point will be changed. This is the first thing. Then, equation of the curves, they also get changed. The most important thing which I wanted to discuss here, that is the reason for making this video. This process is of great advantage. At times it can solve some problems very easily. That I am going to demonstrate with one example. There can be many more examples. So let's see, first of all, how does transformation takes place. One, we say by translation of axes. Shifting the origin to a given point in a plane without changing the direction of coordinate axis means they are taken parallel to themselves. For example, this is your axis right now. So if you take axes parallel to themselves and shift the origin to another place like this, you take the origin to a point hk. So this becomes k and this becomes h, and then this is your new origin, right? Which is o dash. So origin is shifted to o dash, o is shifted to o dash, that means hk. This process is called translation. The other process is called rotation. In this process, we just rotate the axes like this. These are the axes, and you just rotate them by angle say theta. So the new axes are this x dash and y dash. The third is translation and rotation. Now, for example, if this is your x-axis and y-axis, and you do the transformation like this, that this is your x-axis and this is your y-axis. So this can be considered as a mix of translation plus rotation. Okay, so this whole operation can be broken into two parts: translation as well as rotation. We'll show you how. For example, this is the translation, and then you rotate it by angle theta. So we are not discussing the second and third case, means rotation and translation plus rotation. We will be restricting our discussion to only translation. Now what happens when axes are moved parallel to themselves, that is in case of translation? Suppose this is your x-axis and y-axis, and this is any point xy, position of point P xy with respect to our x and y. Now what happens? You do the translation. This is your x and this is your y. Now when you do the translation, say you shift the origin from O dash, that is HK. So this is H and this is K. Now you can easily see this is the new coordinate x dash as per the new axes x dash and y dash, and this is the new coordinate y dash of the point P. It can be easily seen. So the new coordinates of P are x dash and y dash. So this is x dash and this is y dash. So it can be easily seen from the figure that x is equal to h plus x dash and y is equal to k plus y dash. That means the new coordinates x dash is equal to x minus h and y dash is equal to y minus k. We'll just write it here. X is equal to x dash plus h, which we discussed, and y is equal to y dash plus k. So the new coordinate x dash y dash can be written like this: x minus h and y minus k. This is the new coordinates. These are the new coordinates. So the coordinates of P are transformed to, you can call it P dash, x minus h and y minus k. What happens to the equation? Suppose we have an equation, any equation, 4x plus 3y plus 8 is equal to 0. This is, any equation we can call pxy is equal to 0. We write it like that. It has x also, it has y also. So what happens to this equation? Fxy is equal to 0. Old equation, instead of x, you can put x dash plus h. That's it. Okay. So this is how the coordinates of a point are changed and the equation gets changed. Now we'll see one problem where it will be quite clear to us what he is telling. Then when the origin is shifted to this -2, 3, find the coordinates of 1, 2 with respect to new axis. Now what is 1, 2? 1, 2 is xy, means old coordinates. This is 1 and 2, and origin is shifted to -2, 3. It means h and k. This is our minus 2 and 3. So he is asking x dash and y dash. Now we already told you that x dash is equal to x minus h and y dash is equal to y minus k. So this becomes x is 1 minus minus 2 and y dash becomes 2 minus 3. So this is 3 and this is minus 1. So x dash and y dash are 3 and minus 1. So the change coordinates are 3 and minus 1. Let's check the answer, and answer is 3 minus 1. This is how you change the coordinates. It's a pretty simple question, but sufficient to explain the concept. Let's take one more question on how we change the equation, how the equation gets changed. When the origin is shifted to this hk, this is your hk, find the transformed equation of 2x square plus 4xy plus 5y square is equal to 0 of this curve. So if xy is the equation, this gets changed to f x dash plus h y dash plus k. So our hk here is given as 3 and 4. So we'll just write, instead of x, we'll write x dash plus h and y dash plus k instead of y. So the equation will be 2 x dash plus 3 whole square plus 4 x dash plus 3 y dash plus 4 plus 5 y dash plus 4 whole square is equal to 0. Now change x dash y dash to xy. 2 x plus 3 whole square plus 4 x plus 3 y plus 4 plus 5 y plus 4 whole square. This is equal to 0. Now this becomes 2 x square plus 6x plus 9 plus 4 xy plus 4x plus 3y plus 12 plus 5 y square plus 8y plus 16 is equal to 0. Now solve this equation. 2x square plus 12x plus 18 plus 4xy plus 16x plus 12y plus 12 4s are 48 plus 5y square plus 5 8s are 40 y plus 16 into 5, which is equals to 80. Now when you solve it, you get 2x square plus 5y square, 12x plus 16x, 28x, 12y 40y plus 52y plus 4xy plus 48, 80 and 18. So it comes to so what's our answer? The answer is 2x square plus 5y square plus 4xy plus 28x plus 52 plus 146. So if you add those 18 plus 128, it comes to 146. So this is the equation, the changed equation of this curve. So I think you must have got the fair idea as to how to find the new coordinates and how to find the changed equation, the new equation. Now we'll discuss what initially I told you, that this process of transformation at times is quite helpful in solving some of the problems. In fact, it can solve some of the problems quite easily. So let me give you that example. But before that, let's recall the formula which I think some of you might have learned in coordinate geometry, or else I'll show you. Length of perpendicular from origin on a line. Suppose there is a line ax plus by plus c is equal to 0, and you need to find the length of perpendicular from origin, like this. So what is the formula for that? If this is p is equal to mod of c, you take only numerical value, upon under root a square plus b square, right? This is the formula for that. For example, if you have a line 2x plus 3y minus 8 is equal to 0, so the length of perpendicular will be, you only take mod of this value, means 8 upon under root 2 square plus 3 square, right? So just remember this formula, because we are going to use this. Now the question is asked, find the length of perpendicular from 1 1 on the line this. The line is 3x plus 6y is equal to 12, and we are being asked to find the perpendicular from point 1 1, means this is the point 1 1. So we are being asked this length k. We are not being asked from origin, but we are being asked from 1 1. So how do you solve this problem? If you don't know the transformation, how will you solve this? Just pause this video, think for a while, and try to get the solution. I think some of you might have got it correctly. It's a bit tedious. It has 4 or 5 steps. I'll just tell you what steps will be required to find. First of all, you have to find a and b, right? This point and this point. So method 1, which is assuming that you don't know this transformation, you will find a and b. Then you will find length of a and b. Then what will you do? You take triangle PAB, which is equal to half into K into AB, right? This is one way. of finding the area of a triangle. The next way will be, because you know coordinates of P, A and B, there is one more method. So first method is half AB into K, and the next method is, which you must have read in coordinate geometry. If you have three vertices as x1, y1, x2, y2 and x3, y3, then area is half mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Okay, then since 1 and 2 represents area of the same triangle, you equate both of them and get the value of k. This is one method. So we'll solve this problem by this method. Let's see. Now we have to find a and b. So for finding a and b, we have to put this line into the form x upon a plus y upon b is equal to 1. That means 3x plus 6y is equal to 12. Divide by 12 on both sides, it becomes x upon 4 plus y upon 2 is equal to 1. That means this point is 4, 0 and this is 0, 2. Right? So we'll just write them 4, 0 and 0, 2. Now you have to find the length of AB. Right? So length of AB is under root 4 minus 0 whole square plus 0 minus 2 whole square, which is equal to under root 16 plus 4 under root 20, which is equal to 2 root 5. So we'll write AB is equal to 2 under root 5. Now area of triangle PAB is equal to half into K into AB. AB is 2 root 5. So this area equals to K root 5. Again, from another method, area of triangle PAB is equal to half mod x1 1 y2 minus y3, that means 0 minus 2 plus 4 2 minus 1 and plus 0 1 minus 0. So this becomes half mod minus 2 plus 4 mod of plus 2 upon 2, that is equal to 1. Now we have found the same area by two methods, so we can equate them. That means K root 5 is equal to 1. That implies that K is equal to 1 upon root. So you must have realized that here there are at least 4 or 5 steps which are required. Now let's try to apply transformation here in the method 2. Just remember that answer is 1 upon root 5. Now if we apply the transformation here, so we will be shifting the origin from here to P, and if we shift the origin from O to P, the equation 3x plus 6y is equal to 12. This can be written as 3x plus 1 plus 6y plus 1 is equal to 12. That means 3x plus 6y plus 9 is equal to 12. That means is equal to 12 minus 9, 3. That means x plus 2y is equal to 1. Now, the length of perpendicular on ax plus by plus c is equal to 0 from origin. What is its value? Mod c upon under root a square plus b square. So here in this equation, the length of perpendicular from origin, because now origin is at P, will be mod of minus 1 upon under root 1 square plus 2 square. That means 1 upon under root 5. So you can see in this case, transformation has simplified this whole problem, and we can solve it quite easily as compared to the method, which is a bit tedious, if you compare it with this method. And there are many more problems can be there, which can be solved very easily by transformation. This is only one example. So this is all which is there in transformation, and you can see the beauty of transformation, how it can solve the problems very easily, how effective it can be in solving the problems. So please don't skip this chapter and do it very thoroughly. I hope the concept of transformation is clear to you all, and you might have enjoyed this video. Thanks for watching this. Have a nice day.